USDA's Virginia Engineering Design Note 614 provides general information concerning the planning, design, and installation of livestock watering systems. The document was written in 2010 and can be obtained online or from any USDA service center in Virginia. The document is a compilation of information gleaned from some of Virginia's most experienced conservation field staff, as well as from technical documents published by USDA and the Cooperative Extension Services of several states. The design note consists of two main parts and several appendices. Part 1 discusses terminology, key concepts, safety, and the overall design process. Part 2 steps through the design calculations for 8 watering system scenarios and demonstrates the use of the Virginia Livestock Watering System spreadsheet. The appendices provide practical information on such topics as water consumption rates, wire sizing, and pipeline pressure ratings. Basic design steps for all livestock watering systems, regardless of energy source, include: Number 1, evaluating the water source for adequate quantity and quality. Number 2, determining the peak flow rate needed to minimize livestock waiting time at the trough. Number 3, computing the energy needed to move water from the source to the troughs, accounting for vertical lift, friction losses, and pressure to operate trough float valves. And number 4, selecting compatible system components to meet design criteria. The Virginia Livestock Watering Systems Excel spreadsheet accompanies the design note and was developed for use by USDA technical field staff. It assists the user in computing water and energy budgets and in performing pressure checks. For the informed user, it can be a convenient tool for comparing design alternatives. In Virginia, utility-supplied electricity will usually be the most cost-effective energy source for powering a water pump. However, when such service is more than 1/3 of a mile away, other sources of energy, such as solar, wind, and stream flow, may be worth considering. Solar-powered pumps are designed to use direct current rather than alternating current. Electricity is generated by light striking photovoltaic panels. Current output from a PV panel will vary with available light over the course of the day, so either water or electricity will need to be stored so that water is available when the sun isn't shining. Systems are classified as either direct coupled or battery coupled, depending on whether power is supplied directly from PV panels or from batteries charged by PV panels. Direct coupled systems typically employ a centrifugal type pump, with flow varying according to the amount of current available. Since no water is pumped when the sun is not shining, direct coupled systems must include either a water reservoir or large volume troughs with enough capacity to supply water over long stretches of cloudy days. Battery-coupled systems allow for pumping over longer periods of time at a steady rate, but are usually more expensive than direct-coupled systems. Wind can be used to provide mechanical power directly to pumps, or can be used to charge batteries to provide DC electricity to power electrical pumps. Wind generators are sometimes combined with solar-powered systems. Not all sites are suitable for wind power generators. Adequate wind speed and clear space can be limiting factors. Wind systems also tend to require more maintenance than solar-powered systems. Water storage is recommended to provide water when the wind isn't strong enough or when the system is being maintained. Hydraulic rams require no electricity and operate continuously as long as the water is flowing from the source. Rams use flow from a stream, valves, and an air chamber to build up pressure to pump water to the distribution system. Only a fraction of the flow from the source is captured, so it is important to have a high-yielding source as well as adequate storage to satisfy peak demand. Flow rate is dependent on the height of the source above the ram. A minimum fall of 10 feet and minimum source yield of 10 gallons per minute are recommended. Due to the pulsing action of this system, steel pipe is recommended for connecting the source to the ram, which can add significant cost. Design Note 614 and the companion Excel spreadsheet are available through the links on this website or from your local Virginia USDA Service Center. The material in this presentation was developed by the Virginia staff of the Natural Resources Conservation Service, an agency of the United States Department of Agriculture. The U.S. Department of Agriculture prohibits discrimination in all its programs and activities on the basis of race, color, national origin, sex, religion, age, disability, political beliefs, sexual orientation, and marital or family status. Not all prohibited bases apply to all programs. Persons with disabilities who require alternative means for communication of program information, such as Braille, large print, audio tape, etc., should contact USDA's Target Center at 202-720-2600. To file a complaint of discrimination, write USDA Director, Office of Civil Rights, Room 326W, Witten Building, 14th and Independence Avenue Southwest, Washington, D.C. 202-50-9410, or call 202-720-5964. USDA is an equal opportunity provider and employer.